Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we are going to continue with multi-step equations, but we're going to talk about multi-step equations involving fractions and decimals, okay? Don't let it scare you. I've got a great method here to get rid of fractions. First of all, I know I'm a broken record, but I want to make sure you guys understand this. What is the goal to solving any equation? Yes, sir. Isolate the variable. Very good. Awesome. And what does that mean? Isolate the variable. What do I want to solve for? I want to solve for x over 1. Yes. Excellent. And what's the important note to always remember? Nope. Thank you. Whatever you do to one side, whatever operation is performed on one side of the equation must be also done on the other side of the equation. Okay, guys, this is the third time that I've seen this. Everyone should have just been like yelling the answers at me by now. Okay, so the reason I do this is not because I want to be a broken record, but it's because I want to be very emphatic about how important this is. So please, guys, learn it. Okay, this is what you want to solve for, and you got to remember that whatever you do to one side of the equation, you must do to the other side. It's just the way it goes. If not, like I said, go to the gym today and try to put 50 pounds on the left side of a dumb bar, okay, of a weight bar, and put 5 pounds on the other side. You tell me how even that workout is, okay? Think about that, guys, please. Okay, so procedures. Okay, this was the procedures from yesterday, so this should be very fresh in your head. What's the first step of any multi-step equation? Excellent. Complete any distributive properties first. Good job, my brothers. Good job. Number 2 was second thing after I distribute. That's exactly right, my brothers. You want to combine like terms on both sides of the equation. Absolutely. What's my third step? Yes, move all the variables to one side of the equation. Excellent. And now I'm left with a two-step equation. So now what do? Undo addition, subtraction. That's my boys. There you go. And number 5 was the last thing I do? Undo multiplication, division. Fantastic. Thank you. Awesome. Great job, guys. So the good news is we don't have to learn any new steps or procedures as far as that goes, okay? Multi-step procedures stay the same. It doesn't matter if they have fractions or decimals involved in them. Now, solving equations involving fractions. Okay. The most efficient way to solve multi-step equations involving fractions is to eliminate the denominators, guys, of all given fractions by multiplying both sides of the equation by the LCD, the least common denominator. Once all of the denominators have been eliminated, you can proceed to solve the equation with ease. Let me explain exactly what I mean. I have 3x over 4 minus x over 3 equals 10. Now, you could do this. Do not write this. Do not write this. You could find the common denominator. That's 12. That goes to 9x. That's 12. So that's 4x. And then you got 5x over 12 equals 10. And then you can multiply by the reciprocal. And then x would equal 24. You could do that. There's not a problem with that. I love doing that. But I'm really good at fractions. I can find common denominators very quickly. I can convert my fractions very quickly. And I know what I'm doing. Okay, so this is fine. It works. There's not a problem out there for you. However, not everyone is in love with fractions the way I am. In fact, most people darn right are scared of them for whatever reason. So let me show you how to combat that in case you have a little bit of fear, you're just uncertain, okay? And that's okay in life to be uncertain. Let's learn how to work around it. You're still going to have to find the LCD there. You're out of luck, Chuck. So what is the LCD between 4 and 3, my brothers? 12. So check it out, guys. I'm going to multiply 12 to both sides of the equation. That means I'm going to multiply 12 to every single term in the equation. So this is 12 times 3x over 4 minus 12 times x over 3 equals 12 times 10. I never write this out. I do it in my head, but again, I know what I'm doing. I don't suggest you do it in your head. I suggest you do this out the long way until you learn. So now, 12 divided by 4 is 3, right? So 3 times 3x is 9x by fraction. 12 divided by 3 is 4, so I got a minus 4x by fraction. And 10 times 12 is 120. So I've got 5x equals 120. Divide by 5, and x equals 24. And you don't have to use any fractions ever again in your life. Ah, you liked that, didn't you? Good. That's the sound I want to hear. The sound of learning. Okay? Good job, brothers. Let's take a look at number 2. 2x over 5 plus 2 fourths plus 5 halves. You could subtract 2 fourths to both sides, find the common denominator, and go from there. Or you could say, all right, let's get rid of these denominators. What's common denominator between 5, 4, and 2? 20. So I am literally going to multiply 20 to everything. So this is 20 times 2/5 x plus 20 times 2 fourths equals 20 times 5 halves. So 5 goes into 20 4 times. That's 8x by fraction. 4 goes into 25 times. 5 times 2 is 10 by fraction. 2 goes into 20 10 times. 10 times 5 is 50 by fraction. Subtract the 10 to both sides. 8x equals 40 divided by 8. X equals 5. No fractions to worry about. It's not bad, right, guys? Takes away the whole fear of these fractions, doesn't it? Makes it go bye-bye. Just learn the procedure. Okay, my brothers? Pretty simple. When you just, practice it and learn it. I know you can do it. Okay. Let's look at 1/9 equals 5/6 minus m over 3. No one wants to work with all those fractions, but I can get rid of the denominators. What do I have to multiply to both sides of the equation to get rid of this? Very good, my brother. 18 is the LCD for sure. So I'm going to multiply 18 literally to everything. So it's going to be 18 times 1/9 equals 18 times 5/6 minus 18 times m over 3. So then this will equal, fuacata, that's, oh, I didn't want that. That's 2 equals 15 minus 6m. Subtract 15 to both sides. Negative 13 equals negative 6m. And now, of course, I divide by negative 6. So 13/6 equals m, or 2 1/6 equals m. So this one would have been a really ugly one because your answer would have been in a fraction. So you would have had a lot of nasty fractions for that one. It's nice to get rid of the denominator. Does that make sense, my brothers? Okay, now, let me show you the problem child. This is the one that gets everybody. So let me explain what to do here. Okay, I have one fraction here. I have many choices though. I can distribute the 3/5 to both of these, okay, and then multiply by the LCD and do all that stuff. However, let's talk about this 3/5 out here. Think of 3/5 like the gatekeeper, okay? And this is the community inside of the gate, okay? The gatekeeper locks the gate. No one can come out of the community. In order for the gatekeeper to allow these people to come out, he's either got to leave or he's got to give the key to everybody, okay? But when they're in parentheses, they can't do anything because they're in this locked little community. Now, I want to get rid of this 5. What's the LCD between 5 and 1? 5. So I'm going to multiply to 5. Here's the danger. I'm going to multiply it to this, and I'm going to multiply it to this. Not to this. Why? Yes, sir. Very good, my brother. What's happening here is you're distributing the 3/5. So this x minus 20 has not been affected by the 3/5 yet. What am I doing right now in this first step? I'm getting rid of that denominator of 5. So I'm multiplying 5 to the 3/5, but I'm not multiplying it to the x minus 20 because the x minus 20 is not x minus 20. The x minus 20 is whatever it is after I multiply this. And then that equals 9 times 5, of course. And then from here, that cancels. So now I have 3 times x minus 20, no more fractions, equals 45. Now I can distribute. Minus 60 equals 45. Add the 60. So then I have 3x equals 105 divided by 3. X equals 35. So when there's something outside, you only multiply to the outside number. Yes, sir, my brother.
For that particular problem,
yes, sir, my brother.
Would it be easier though to just distribute?
Yes, it depends. It depends on you. Okay, the question is, Mr. Morrow, but I'm pretty good at this. Couldn't I have just distributed it? Yeah. You could have done this. 3/5 x. 3/5 times 20 is negative 60 over 5, which is negative 12, equals 9. Then I add the 12. Then I add the 12. Then I got 3/5 x equals 21. Then I multiply by 5/3. Multiply by 5/3. X equals 35 as well. Yes, the answer is yes. But it's not really, this isn't, I'm not trying to teach you this is the way you have to do it. This is just another way to help you out. Where this is going to be more useful is in something like, here, let me give you an example here. Let me give you, whoa, that's not what I wanted. Let me give an example here. What if I gave you something like this, brother? I'm going to make it up, okay? I'm not going to make something up that you wouldn't see, though. Let's say I told you 3/4 x minus 2 plus 1/8 2x plus 5 equals 3/5. Are you going to want to distribute that one out? No, right? Because it's too much. So I'm agreeing with you. When it's simple, guys, I'm not showing you this to make your life more difficult. If you can do it, by all means, may God bless you. Awesome. I mean, seriously, go for it. But now something like this is going to get nasty. So what I'm going to do is I'm going to multiply everything by my LCD of 40. But this 40 will affect the 3/4. It will affect the 1/8. And it will affect the 3/5. Not inside of here. Not inside of here. Does everyone understand what I'm saying with that? Yes, sir, my brother. Because 32 is not a multiple of 5. Thank you, my brother. So then this would be 40 times 3/4. That's going to be 30 times an x minus 2. Plus 40 times 1/8 is a 5 times a 2x plus 5 equals 40 times 3/5, which is 24. And then from there you can solve. Does that make sense? Does that help you, my brother? Thank you for that question. It was a brilliant question, by the way. Yes, sir, my brother. Okay. It makes it impossible, right? Yeah. Okay. This was you guys are asking me some great questions. I'm very proud of you. Okay. The question here was like, for example, for this guy. The question that I was just asked was, Morrow, why can't we just multiply by the reciprocal? Okay. This goes back to yesterday's lesson. At what stage does the equation have to be at for you to be able to use that reciprocal property? When can you use that? When can you use that, guys? When it's a single step equation. Is this a single step equation? No. So you do not want to do that. Oh my goodness, if you multiply everything by the reciprocal, now you have a big mess. You multiply by reciprocal when it's like this. Okay, I have a one-step equation. Now I can multiply by 5 over 2. Now I can multiply by 5 over 2. And then x would equal 15/8. You feel me? But you cannot do that here. That only works for a single step. If you have a multi-step with fractions, you got to multiply everything by the LCD if you want to get rid of the denominators. You with me? Thank you, my brother. Okay, now, okay, here. I don't know why, but this messes people up big time, okay? So I'm going to show you how to do this the easiest way possible. You could go ahead and multiply everything by 4. Yeah, you can. But I think I have an easier way. Guys, if I put a little 1 under here, didn't I just form a proportion? Cross multiply, y'all. So I got x minus 3 equals 32. Don't even sweat it. Yeah, see? Not that bad. Not that bad. Not that bad. Yes, sir, my brother.
Why can't you simplify the four negative?
Come again? You can't simplify the 4 and 8 because they're not being multiplied. If it was x minus 3 over 4 times 8 over 1, yeah, then I can make that a 2. But then that'd be an expression, not an equation. You have an equal sign, so you cannot do that. Thank you, my brother. Now here, cross multiply. So I got 2x minus 5 equals negative 6. Add 5 to both sides. 2x equals negative 1 divided by 2. X equals negative 1/2. Does that make sense? Okay, now, and these, we get a little bit uglier, but please don't stress. Whenever you have a proportion, literally just cross multiply. So this is a 5 times 3x minus 5. Make sure you remember you're distributing this. Equals 3 times a 2x plus 1. So this is 15x minus 25 equals 6x plus 3. Now I subtract 6x to both sides, and I get 9x minus 25 equals 3. I go ahead, hold on, let me erase this part. You go ahead and add 25. 9x equals 28 divided by 9. X equals 3 1/9. Just cross multiply. Okay? It's that simple. And then last but not least, I have a proportion, cross multiply. 3 times x plus 3 equals 4 times x minus 5. So this is going to be 3x plus 9 equals 4x minus 20. I'm going to go ahead and subtract 3x to both sides. I got 9 equals x minus 20. Add the 20 to both sides. 29 equals x. Sir, my brother.
And you wouldn't recommend to do both at the same time, right? Subtract minus 3x and plus 20 at the same time.
Okay, you're saying add the 20, subtract the 9 at the same time?
No. So, add the 20 on both sides and subtract the 3x.
Okay, yes. In my head, I do it all at once, but I don't want to teach it that way because it may, if I skip a step, it may work for you because, okay, you saw it, but there's going to be a couple people that doesn't work for. So, but yes, what my boy asked is, can't I go ahead and do multiple things at the same time? So, for example, could I have subtracted the 3x and added the 20 all in the same step? Yeah, you could have, but I don't like to do that, me personally, because I find that when I do that, I tend to make mistakes. Me, but that's okay. Thank you, my brother. Does that make sense, guys? Okay, now, okay, decimals. A lot of words, but that's why I wrote it for you, so please listen to me. The most efficient way to solve multi-step equations involving decimals is to eliminate the decimals of all the given values by multiplying both sides of the equation by the correct power of 10, okay? In order to find the correct power of 10 to multiply by, Simply look for how many numbers are to the right of the decimal point and multiply by the power of 10, which matches the number of values to the right of the decimal. Once complete, all decimals have been eliminated, and you can proceed to solve the problem or equation with ease. Now, let me explain what this means in English. Note, look at each value. Okay, so I'm looking at each value. How many numbers are to the right of each decimal? How many numbers are to the right here on 3.5? 1. How many decimals here? How many decimal values here? Okay, what is the largest number of decimals here? So I'm going to multiply by a 1 with 2 zeros. So I'm going to multiply by 100. So I am literally going to multiply by 100. Why? How many zeros in 100? How many decimal places? I always go to the largest decimal place. So now, guys, just like I did with the fractions, I'm going to make all the decimals disappear, go bye-bye. So I'm going to literally multiply everything by 100. When I multiply by powers of 10, I move the decimal to the right for as many places as there are zeros. So 3.5 goes 1, 2 to the right, so that becomes 350, my brothers. Minus 1, 2 to the right, that becomes 2x. Equals 1, 2 to the right, that becomes 124. No more decimals, bye-bye. Okay? Some people like working with decimals. Good for you. God bless you. I'm not going to penalize you for that. Some people love decimals. Great. Some people don't. I've given you options here. So now I'm going to subtract 350 to both sides. Please remember, my brothers, that when you add numbers with opposite signs, you got to subtract as normal and keep the sign of largest absolute value. Just please remember that. That's 226. And then divided by negative 2. Oh, look at that. What a pretty number. Negative 113. No decimals to have to worry about. None of those decimal lineups or anything. Yes, sir. Wait. Ah, it is negative. Learn how to pay attention, Mr. Morrow. Thank you, son. Thank you very much. Practice what you preach, Mr. Morrow. Pay attention. Thank you, sir. Does that make sense? It's not bad, right? Okay. Now, I'm going to do the following. I'm not going to solve all of these. I have about 3 minutes. And I'm scared that most of you, if I do take the time to do it, most of you won't watch it. So I'm going to show you how to do the setup from here, and it is your responsibility to solve the equation. Okay? I'm going to show you how to do the setup, though. I got a 1.2 times parentheses 2x minus 5 equals 9. I could go ahead and just multiply by the 1.2, but I'm going to teach you this whole lesson is to get rid of the decimals. So I'm going to go ahead and multiply everything by, how many decimal places do I have? So what am I going to multiply by? 10. Now, it affects this guy, but it does not affect the parentheses. Remember, same as the fractions. Does that make sense? Okay. So I've got 10 times 1.2 and 10 times 9. So I go 1 to the right. I've got 12 times 2x minus 5 equals 90. And then you solve from there. Number 3, what's the largest number of decimals that I have? So what am I going to multiply both sides by? 1,000. I'm going to multiply everything by 1,000. When I multiply by 1,000, I move the decimal to the right. How many places? 3. So this becomes 1,025x plus 2,458 equals 7,583, because I went 1, 2, 3 to the right. 1, 2, 3 to the right. 1, 2, 3 to the right. And last but not least, I'm not going to solve that, guys. You're going to have to solve it on your own. And last but not least, what's the largest number of decimal places that I have here, for example, 4? So I'm going to multiply everything by. Okay, now pay attention to this one. Goes to this guy, only this guy, no to the inside, because that is not being affected. Now, this becomes 1, 2 to the right, 15x, plus 1, 2 to the right, 250, equals 1, 2 to the right, 12, times 3x minus 4. And then you can solve from there. Does that make sense? I gave you magic today, guys. I gave you the key to the city. Have a great day. Thank you very much. Hope you learned a lot. Bye-bye.